Welcome back, ladies and gentlemen, to the free response question review for Calculus BC. Today we'll be focusing on the 2016 exam, question 1, using a graphing calculator. So here is the problem. It's your standard table problem with water being pumped into a tank at a rate modeled by W of t equals that thing in liters per hour between 0 and 8, where t is measured in hours. Water is removed from the tank at a rate modeled by R of t liters per hour, where R is differentiable and decreasing on 0 to 8. Selected values of R of t are shown in the table above. At time equals 0, there are 50,000 liters of water in the tank. Alright, so before we get started, just to let you guys know, I have the function already put into my calculator. If you need to, go and hit the pause button so you can have the calculator ready for you as well. And so it says, estimate R prime of 2, show the work that leads to your answer, and indicate units of measure. I think we can do that. So A, that is going to be R prime of 2 is going to be approximately equal to classic Algebra 1 integrated 1 slope problem. We don't have a time equals 2, so what I'm going to do is I'm going to squeeze that 2 in between 3 and 1. Those are the closest relatives to it. So I'll go and say R of 3 minus R of 1 over 3 minus 1. So that's divided by 2, so that's going to be 950 minus 1190, and that's going to equal negative 240 over 2, or negative 120. And in this case, since they want me to indicate units of measure, this should be liters per hour squared. Okay, pretty simple so far. It says in part B, use a left Riemann sum with 4 subintervals indicated by the table to estimate the total amount of water removed from the tank during the 8 hours. Is this going to be an overestimate or an underestimate? And give a reason for your answer. So, I know I scrolled down past where the table is, but I'm hoping you will have your prep books in front of you. That way you can see when I go to graph this thing. If I'm going to use a left Riemann sum with 4 subintervals, then I'm going to go and just graph real quick. I think that'll make my life a little bit easier. So according to the table, I've got 0 to be 1340. 1 is going to be 1190. 3 is going to be 950. And again, I'm just kind of estimating where these are. 6 is going to be 740. And then 8 is going to be 700. Okay, so from here, my left-handed sum, the heights will come from the left sides of each rectangle. The left sides of each rectangle here. And here we go. So that means if I'm going to find out the total amount of water removed, that means I'm going to be integrating from 0 to 8 of R of t dt. Again, I have to emphasize R is a rate already, so if I want to find out how much was actually removed, I'm going to integrate that rate. So again, we just want to find out the total amount of water removed. I don't care how much water was going in. I don't care about how much water was there. I'm just going to talk about the water being removed. So this is just going to be a bunch of rectangles being added together. So my first rectangle is 1. Since it's a left-handed rule, I'm going to go ahead and add 1340, or rather, when I say add, I really meant multiply. And then plus 2 is my next base. My height at that moment of time is going to be 1190. And then plus, I'm going to bring myself down here a little bit, 3. And then my height at that time is going to be the 950. And then plus my last rectangle width is going to be 2. And my height at that time is going to be 740. And after all that is done, I'm going to get 8,050. Now it says it never indicates that I should be putting units in, so I'm just going to go ahead and just I'll go and just put that in there. But if I wanted to integrate liters per hour, then I would be removing 8,050 liters during the time interval 0 to 8. Now, the second part of this question is asking, is this an overestimate or an underestimate for the amount of water removed? Give a reason for your answer. Well, we're using a left-handed rule here, and the function is decreasing. So if the function was decreasing, I feel like my rectangles would be above the function, regardless of the concavity of it. So I would then say that the estimation is under, because we are using a left-hand rule, and r of t is decreasing. Pretty simple so far. Again, it's a pretty simple FRQ. This is a BC question, but it was also a guest star in the AB exam. So there's actually quite a bit of AB on this. Very, very doable. Very, very doable. All right, let me go and clear off the board real quick so we can move on to C and D. Part C is asking us to use the answer from Part B to find an estimate of the total amount of water in the tank to the nearest liter at the end of 8 hours. Okay, if I want to find out how much water is in the tank, I have to consider three things. One, I have to consider how much water was already there. And then I'm going to add the total amount of water that went into the tank, and then I'm going to subtract the total amount of water that has exited the tank. So, what does that look like? Well, we started at 50,000. The problem told us that. We have 50,000 liters of water in the tank. And I'm going to go and add the integral from 0 to 8 of how much water went in. Well, that's dictated by this e function up here, this w of t. So, w of t dt. And then I'll go and subtract from 0 to 8 of r of t dt. That's going to give me how much water has left. But we already know what that is. It's 8,050. We found that out in the last problem in Part B. So 50,000 here, plus, then I got to figure out what this thing is. Luckily, we have a calculator that will do that for us. So I will go shift plus from 0 to 8 of f1 of x dx. I'll hit enter. That is how much water went into the tank. So what I'm going to do is I'm going to go and say, all right, 50,000 plus that answer, and then minus 8050. And now I'm going to go ahead and round that to the nearest liter because the problem asked me to, which means this guy's going to truncate off. So my answer here is going to be 49836. All right, awesome. Okay, it says Part D, for 0 to 8, is there a time t when the rate at which the water is pumped into the tank is the same as the rate of the water being removed from the tank, and explain why or why not? How do we figure this out? Well, they're asking me on 0 to 8, basically, does the rate in equal the rate out? Does it ever? That should be a question mark. In other words, what they're saying is, does W of t ever equal R of t? Does it ever do that? Well, another way of looking at W of t equals R of t would be looking at it like this. W of t minus R of t is equal to 0. And if I know that these two functions are continuous on 0 to 8, if I can find a time where these two functions are bigger than 0, and then another time in this interval where these two functions are less than 0, then I feel like they will equal 0 using an old property and an old friend called the intermediate value theorem. So if I'm going to use intermediate value theorem, I have to first establish something that I already know. And that is that these functions are differentiable. And when they're differentiable, it implies that they are continuous. So let's write that down before we do anything else. W of t and R of t are differentiable and therefore continuous on 0 to 8. Once I establish that, then I am in bounds to use the intermediate value theorem. So let's go ahead and find out what these things are. Well, let's find out what W of 0, actually, I'm going to move them up. I'm running out of space here. W of 0 minus R of 0. Well, what type of number is that? Well, W of 0 is 2000 minus 1340. And that is greater than 0. Well, W of 8 minus R of 8. Well, what's W of 8? Let's find out what that is. Let's put you in something that's a little more comfortable for us to look at. That 81.524. 81.524 minus, well, how much is R of 8? R of 8 is 700. Meaning this is less than 0. I hope we are starting to see where this problem is going. And therefore, we can say, therefore, by IVT, there exists a value on the interval 0 to 8 where W of t minus R of t equals 0, and therefore W of t equals R of t when you add R of t to both sides. Okay, I think that just about wraps it up for this problem here. If you have any questions or comments, go and leave them in the comments section. I look forward to hearing from you, and I will see you in the next video.